Okay, today I'm going to talk to you about melting and boiling points. So I'm going to show you how to figure out which state different substances are based on information about their melting point and boiling point. So first off, let's just imagine it is, we're in a room. So our room temperature is, let's say this particular room is 20 degrees Celsius. So what I've got to do is, given this information, I have to figure out the state of these three different things at room temperature of 20 degrees. Now you might already know, or should already know, the state of each three of these would be in at room temperature, but I'm going to show you how we can figure out. Let's say these were mystery substances. So the first thing that you need to do is you need to draw yourself a scale. So it's like a temperature scale, like this. So the most important things we have on there, we mark on 0 degrees Celsius, and we also mark on our room temperature. So our room temperature, let's say, is right here. And let's say, yeah, for this room, it's 20 degrees C, okay? Now, please, the really important thing about this scale, this kind of temperature scale, is it's not to scale. It's just rough, so we could get the idea of which substance is going to be a solid, a liquid, or a gas at room temperature. So in fact, before we move on, we need to know what melting and boiling actually means. So just to be really, really sure that we do, melting is when a solid turns into a liquid. So when the particles are given enough energy to overcome the forces to turn a solid into a liquid. Now, boiling, so the boiling point is when the particles have enough energy to overcome the forces in the liquid in order to become a gas. So boiling is turning from a liquid to a gas. Okay? So let's start off with oxygen. So here's my temperature scale. So here's my room temperature, here's 0. So the melting point of oxygen is much less than 0 because it has this minus number, it's much less than 0. So it's all the way down here. So my melting point, again, remember it's not to scale, this is just getting the idea in relation to 0 and our room temperature, where it is. So my melting point is minus 219 degrees C. Okay? So that's the amount of energy required to turn solid oxygen into liquid oxygen. Its boiling point is a little bit less cold. It's still a minus number, so it's not above 0. So it's going to be somewhere like this. So there's the boiling point of oxygen, which is minus 183 degrees C. Okay? So when I'm figuring this out, what I like to do personally is I like to imagine we're starting the left side of its melting point. So imagine we have solid oxygen right here. So what we need to do is slowly, we're going to move until we get to room temperature and think what's happening to oxygen as we go this way. So the moment we have solid oxygen. So as we increase the temperature, bam, we hit the melting point right here at minus 219, very low melting point. So this means this much energy, at minus 219, the particles have enough energy to turn from a solid to a liquid. So now oxygen is in a liquid state. Remember, we've seen when we get to room temperature, what state will be at room temperature. So let's keep on going because we haven't reached there yet. Right, bam, at minus 183, we hit the boiling point. That means there's enough energy now to turn oxygen from a liquid to a gas. So oxygen is now in a gaseous state. So we keep on going, it's still a gas. So when we get to room temperature of 20, we know that oxygen is a gas. Please remember, this scale is not to scale. Right, so next up, let's imagine we're looking at water. So again, we look at our scale and we mark on our melting point and our boiling point. So water's melting point is 0. So our melting point is right there. Now the boiling point is above room temperature, because room temperature, remember, in this case is just 20. It's above room temperature. So our boiling point is 100 degrees C. Again, this is nowhere near to scale. I just need to see where it is in relation to room temperature. Is it above it or is it below it? So again, let's imagine we'll start this side of the melting point, this time with solid water called ice. So as we heat it up, still solid, bam, here we reach the melting point. So at this point here, it's enough energy to turn it from a solid to a liquid. So now water is a liquid. So let's keep going till we reach our room temperature. Okay. At room temperature, Therefore, water is liquid. Because we've got enough energy for it to have turned from a solid to a liquid, but we haven't got enough energy to turn it to a gas. We haven't gone over the boiling point. So as a result, at room temperature of 20 degrees, water is liquid. So we're going to have a look at the final one now, iron. So now iron has a really high melting point. Again, this is not to scale. We just need to see where it is. So it's above that of 100. So let's say there's our melting point of iron, which is 1,538 degrees C. And there is our boiling point of iron, which is 2,862 degrees C. So again, let's start right down here. Imagining we have solid iron. So as we heat up the iron, giving the particles more energy. But it's still a solid because we haven't reached the melting point. Right. So at room temperature, it's a solid because we haven't got enough energy to melt it. We have to get to 1,538 degrees C for it to be a liquid. Because that's its melting point. So that's how to do it. So just a quick recap. The first thing you need to do if you want to find out what state different substances are at room temperature is you draw yourself a little scale. It doesn't have to be the scale. You then need to just draw on the melting point and boiling point. Always imagine starting at a solid and working that way towards the temperature you're trying to get to, and you can figure out which state it is. Thank you very much.